Okay, in this video we're just going to kind of review some of all of the things we've learned with Convergence and Taylor series and some kind of AP type questions. So first of all, the interval of convergence. Well, remember we always set up the ratio test. So the limit as n approaches infinity has to be less than 1. We do our algebra. So we end up not having any n's left. We just have a 1/2 multiplied by x minus 3. So let me just write that. So on top we have an x minus 3. On the bottom we have a 2. So again, I can yank all of the stuff that doesn't have an n, I can kind of yank out front. So I'd have, I'm going to write it as 1/2 instead of divided by 2. Since there was nothing left in there, I'm just going to write it as a 1. So of course this right here, this whole thing is just 1. The limit as n approaches infinity of 1 is 1. So I end up with 1/2 x minus 3/2, you want to think about it that way, be less than 1. Okay, so then we set this up, we have negative 1, 1/2 x minus 3/2 less than 1. Okay, so we add 3/2 to both sides, so we got 1/2 multiply everything by 2, something like that. Okay. So now remember we need to check those endpoints. Okay, so let me just do that kind of right below here if I can. Okay, I'm going to try and create myself just a little bit of room. Like that. If I plug in 1, so 1 minus 3 to the n. So I have negative 2 to the nth power over 2 to the n plus 1. Well, that's the same as negative 1 to the nth multiplied by 2 to the nth, okay, over 2 to the n plus 1, and then the 2 stuff kind of cancels, so it's just negative 1 to the n over 2. Well, that is divergent. Okay. The other one I need to check is x equals 5, and in that case I get 2 to the n on top, 2 to the n plus 1 on the bottom. Well, that just reduces to 1/2, so these both diverge. So this is the interval of convergence. I don't need to say anything about equal to the endpoints, but remember, check the endpoints every time just to be sure. Okay, determine the coefficient of the 12th degree term of the power series representation for that function centered at x equals 0. Well, I look at this and I start to think, first of all, centered at x equals 0 means it's a Maclaurin. Okay, I'm just going to write Mac right there, it's Maclaurin. And to me, it's really similar to 1 over 1 plus x. Just really similar to it. I can multiply it by 3, I can put in a 2x cubed instead of an x, but it's similar. Remember that this, I'm going to put an approximate symbol here because I'm not going to write the whole thing out. This is the alternating, 1 minus x plus x squared minus x cubed plus x to the 4th, and so on. Okay, if I need more, I'll build more. So if I multiplied it by 3, if I changed it like this, that's just multiplying every term by 3. So 3 minus 3x plus 3x squared minus 3x cubed. Because if I multiplied the function by 3, I can multiply the polynomial by 3. Well then, instead of x, though, if I put in a 2x cubed, well, that means every time I see an x, I'm going to write a 2x cubed. Okay. Now let's just kind of start maybe simplifying this a little bit. So this is 3. This is 6x cubed. Now remember here we're going to have 2 squared, so it's going to be 4 times 3, so it's going to be 12x to the 6th. Here we're going to have 2 cubed, so we're going to have 8, so it'll be minus 24x to the 9th. And here we're going to have 2 to the 4th, which is 16. 3 times 16 is 48x to the 12th. So we wanted to know the coefficient for the 12th degree term. It is 48. 48 is the coefficient for the x to the 12th term. For the Maclaurin series below, find the value of the 4th derivative. Well, remember, for Maclaurin, we always have the value of the derivative, right, at 0. We have x to that same power, and then n factorial on the bottom. Of course, the only difference with a Taylor is it's, a here and x minus a to the nth. So the 4th degree, or the 4th derivative, must go with the 4th power, right? X to the 4th. So I know that the 4th derivative at 0 times x to the 4th over 4 factorial. I know that that's equal to 11x to the 4th. Well, of course, the x to the 4ths don't really matter here. It's like that. So if I say, all right, the 4th derivative at 0 divided by 4 factorial is 24, that's equal to 11. Well, I multiply 24 both sides. So I end up with the 4th derivative at 0 being equal to 264.